Okay, thank you for the introduction and good afternoon. First of all, I hope you are well despite the situation we are going through. And I want to thank you, your interest and the participation in this webinar. So today we are going to talk about the surface measurement in tooling. This presentation is divided in 4 sections. The first one is an introduction of our company. Then we will pass to a short overview of our portfolio. Then we will talk about a little bit of the techniques that we can find in our sensor heads. And then we jump into the tooling application, which is the topic that concerns us today. So Sensofar is a company founded in Terrassa, which is really close to Barcelona, just 15 kilometers far away, in 2001. Since 2001, we have been designing and manufacturing optical instrumentation for the characterization of micro and nanoscale surfaces. With that, we can provide solutions for quality control, quality inspection, and R&D. Here we can see a picture of our headquarters, which are located in Terrassa. Here we can find, for example, from the production team, software, marketing, management. And then we have other offices all around the world, which are sales offices. We have one in Asia, another in Germany, and another in USA. We have a worldwide presence, and we have to thank you to our network distribution to help us to give the best experience to our customers that we can find all around the world. Here we can share with you some of our partners and some customer references. Maybe you know some of them. For example, for this application of tooling, we can highlight maybe some Swiss companies or some Swiss institutions. We also work with NIST and PTV and so on. So now we can make a short overview on our portfolio. If we start from the left, we can see the SY. This is our newest system. It has been launched this last spring into the market. It has been designed with the idea to make a fast acquisition in one single shot of large areas. Close to him, we can say our 5-star product, which is the SNEOX. Here we have 3 technologies in one, we will see after. And close to him, we have the 5-axis. We have the same sensor head as the SNEOX, but with this rotational module that allows us to make a full 3D shape of our sample. And we have the links and the sonics, which is an interferometer with really fast acquisition. We have also the option to work with integrable heads. This is the purpose of this is to integrate, for example, the S-Wide or the SNEOX Smart or Sonics in a line production. It could be, for example, in a machine, in another machine, or in a robotic arm. So after this short overview, it's the time to talk a little bit about the technologies that we can find in our sensor head. And for that, I'm going to focus on the SNEOX. This is our confocal. We can say that is our ship flag system. And you can see here all the evolution of the SNEOX. In front, we present the 5th generation of this system. Now, in fact, it has been launched into the market 1 year ago. And during these 20 years, we have been measuring and characterizing surfaces, shape, and roughness. And how we can do this? So we can do this by using different technologies in the same sensor head. We have the option of active illumination focus variation, or confocal, or interferometry, or spectroscopic reflectometry. In the case of measure smooth surfaces with the slopes up to 86 degrees on scattering surfaces with a fast acquisition time that we can reach 200 planes in 3 seconds, the best technique will be active illumination focus variation. But if we are more interested in obtaining the best lateral resolution, which is close to 140 nanometers, we will choose confocal. With this technique, we can also achieve speed measurement comparable to active illumination focus variation if we work with continuous confocal mode. But imagine that our interest is to measure features in our sample with a system noise down to 0.1 nanometer, or measuring large field of views with nanometrical system noise. No matter with the objective that we are using, we will choose interferometry. And then we have the option to measure transparent films from 50 nanometers to 1.5 microns. So in that case, we will choose the spectroscopic reflectometry. And here we want to share with you a summary table. In the right part, we have the different technologies that we can find in our sensor head. And on the left, we have the features that maybe are our interest to measure. For example, if we want to measure high local slopes, we will choose the 3 stars. It means active illumination focus variation, sorry. Or maybe in the case, if we want to measure nanoscale features, the best option will be interferometry. Another thing which is important is that our systems has a light source based on LEDs. In fact, we have 4. We have the red, the green, the blue, and the white. Why? Because this gives us more versatility to the system, and it is useful for measuring different reflectivities. Another benefit, for example, against the laser is that we can obtain less scattering. It has longer lifetime, and LED is cheaper if we need to replace. So after that, we are going to focus, to explain a little bit, which is the most used system in tooling application, which is our confocal SNEOX 5-axis. So this system allows us to measure the 3D shape surface of a part. Okay, we have here the sensor head, and here we have the rotational module. This rotational module, we can see here the detail. We have the holder, and here we have the part, our sample. So what we can do is to rotate in different positions and different elevations. For the rotation, we can cover 360 degrees, and for the elevation, we can cover 140 degrees. Then we can make the merge of different elevations for providing shape and form information. So the software of this system has been designed with the idea to be really flexible. What does it mean? So for example, if we want to measure concrete areas, we have the option, for example, to go to multiple axis position. We can create automatic routines. We can measure single points, single field of views. Or if we want, for example, we can measure in complex surfaces with steep angles. We can tilt the sample, and we can make an extended measurement, for example, and then we can merge. Another thing which is really interesting is that we can achieve cutting-edge radius down to 150 nanometers. And then another thing that we don't have to forget is that our system has the 3 techniques in the same sensor head, that we can achieve radius of 350 microns in cylindrical shapes. And this slide is just to know that for those budgets with some limitations, we can use, instead of the rotational module, we can use this support in the case that we want to measure the cutting edge of an insert. We can attach the support to the table. Above the table, we have a tip tilt, and thanks to the interferometric technology that we have in the sensor head, we can be sure that we are perfectly aligned, and we can measure the cutting edge. So now it's the time to jump into the tooling application. So what is the tooling? Tooling is a set of tools, especially ones required to manufacture a particular component, part, or assembly. There are many different types of tooling. I'm sure that maybe you are more familiar than me. So for example, we can say work holding tools or cutting tools for milling and grinding machines. If we talk about the markets, we can find tools in a lot of markets. For example, we can go from aerospace and automotive, and then we can go down until watch manufacturing. Here we have some examples that we are familiar to. We have the screws, the cutting tools, and the drills. So with our confocal 5-axis, we can perform a surface characterization. Why? This is important because we'll obtain information from our tool. So we know that a proper tool has a direct impact into the quality, the output capacity, the product life cycle, and the price. So here, from the topographic evaluation, we can obtain different information, as can be the shape, the wear, the cutting edge, and the roughness. And maybe you ask, but okay, why we have to choose Sensofar for those kind of applications? So because with our confocal SNEOX 5-axis, we can obtain a full 3D shape. We can characterize this sample, and we have 3-in-1 technologies in the same sensor head. How we can work with this system? Here I show you a really short workflow. It consists of 3 steps. The first one consists on define the settings in the software and make the acquisition. Then we merge the topographies, we prepare the data for its further analysis. In our case, we work with Geomagic, Control X, and Grab for doing the 3D comparison and dimension study. But in the market, there are many other softwares that, if you are familiar to work with, are a good option too. So here we can see a drill tool. This is the confocal SNEOX 5-axis. We have the sensor head, the bridge, and here we have the rotational module. Here on the right side, we see the detail with the drill tool, which is held in that region. We are going to obtain a full 3D shape with concrete rotation and unspecific elevation. So here we want to show you some examples of real measurements, and in that case, with the help of Utilis. Utilis is a Swiss company which has been focused for, I think, almost 1 century in producing, developing, and distributing high-quality cutting tools for machining, for wet industry, and for medical applications. So the first example is a Skew Thread. Here on the left part, we can see the part which is held in that holder. We have the option in the software to choose, for example, different measurement types. In that occasion, we have the sector measurement type. We can define a range of degrees in the rotational axis, and in that case, we use a 5x magnification, and we spend 6 minutes to cover 29 field of view, and the measurement has been taken with active illumination focus variation. Here on the right side, we can see the reconstruction of the 3D. We have a height in that flank of 1.5 millimeters, and in that case, we use the ring light to be sure that in that flank, the light reaches this flank. The next example is a drill tool with a 5 millimeter diameter. In that case, we have chose the circle measurement type. That means that we cover 360 degrees in the rotational axis. We spent 5 minutes to cover 20 field of views, and we have used the 5x magnification. This example is a bone screw. We can see we have the inner diameter, which corresponds to 2 millimeters, and the outer diameter to correspond to 4 millimeters. Here, in that case, we have the cylinder type measurement. We can understand this like we make a circle and then we extend the measurement. For covering 45 field of view, we spend 15 minutes. So one of the things that we can do is to make a 3D comparison. For example, once we have the full 3D shape. And here we can select parameters, extract deviation. And one thing that we want to say is that we can export different formats for 3D mesh format and also for cloud of points. This example, it corresponds to a watch screw. Here in the image, you can see it's really small. The diameter is less than 1 millimeter. It came from another Swiss, but in that case, it's not a company, it's an engineering school. focus on watch industry. And in that case, we choose again the cylinder type measurement. And in that case, we choose the 550x extra long working distance length for to be sure that we reach these small parts. We spent 2 hours and 19 minutes to cover 191 field of views. When we have the 3D, we can make a cross section, and then we can obtain different distances between different points, different features which are of interest. Another analysis that we can do is profile extraction. If we have this part, the 3D, we can apply the unroll to remove the cylindrical shape, and then we can make the profile and we can obtain different measurements as the angle, the radius, and the distances. Okay, another thing which is important in tooling is the cutting edge. So why is it important to study the cutting edge? So as we know, as a tool wear increases, may cause tool failure and contributes to increase the manufacturing cost. So for reducing this and improve the production rate, it's essential to study the cutting edge. For this reason, it's important to understand how the cutting tool is going to interact with the unfinished surface. So in this draw, we can see here, it corresponds this to the cutting tool, and this is to the unfinished surface. So there are different parameters which are going to give us information about how is our cutting tool. Here we have some of them. We have the rake angle, we have the angle between flank and rake faces, and the clearance angle. So how we can do this? So we are going to use our confocal SNEOX 5-axis. We are going to take all the benefits of the rotational module. We are going to place our part in the holder here in the rotational module. And with the Sensoscan 5-axis, which is the software dedicated for the acquisition, we are going to introduce different settings for be sure that we have the region of interest in focus. Once we have the topography of our region of interest, we can analyze. We can analyze with the SensoView or with the Sensofar, for example. Both are a property of Sensofar softwares, and we can say that SensoView will help us to see in a fast mode how looks like the topography. And then the SensoPro is another software which is designed for an automatization of the analysis. We work with different plugins. There we can define different parameters that are going to help us to analyze the future at the feature of interest. And then we can generate, for example, and pass and fail report if we have the tolerances of these parameters. So one of the examples of the cutting edge that we want to show you is the one that we can see here in this slide. On the left part, we have the topography of the cutting edge. Here we have done an extended measurement. Depending on the case, with one field of view will be enough, and depending on the case, we'll need more field of views. In that case, we work with 3 field of views, and we use a 100x extra long working distance. Here we can see the profile that we can read with the SensoView, and we obtain a radius of close to 4.5 microns. But if we want to go to the SensoPro, I have here a screenshot of the software. Here on the top part, we have different plugins. We can do it under request of the customer. And here we have chosen the Edge plugin. We can see different parameters that define the feature that we are going to study. And we have different here, the parameters that are going to show once the analysis has been done. So when the analysis is done, we'll see this chart of here with all the parameters and the statistical value. And then we have here a single parameter, and this is the representation of each of the profiles that we have selected. Also, in the central part, we have the output view. We have, this is the profile fitting of with the cutting edge, and we have different parameters that are going to give us the information of this cutting edge. Another thing that we can do is study the roughness. The roughness were in that region here, in that part, okay? The parameters correspond to Ri, Rq, and we have the average and then the standard deviation. And finally, just to give you the idea that we can measure, thanks to the versatility of our system, is the diamond tool surfaces. We can use here the interferometry with a 10x DI, and just with one field of view and 3 seconds, we can obtain all the roughness parameters, the surface parameters of the roughness following the ISO 25178, and that's all. So thank you for your attention, and I think maybe there are some questions. I don't know. Okay.
So if you have any questions, just ask them now using the question mark button on your interface and write down the question, please. So there are no questions so far. No. In that case, thanks a lot, Sandra.
No, thank you.
If you have any questions that appear to you after this presentation, you can contact Sandra on via the address in your webinar planner, or you can contact the METAV staff to pose your question. So,
okay, thank you.
Thank you for all of your attendance. And you can also download your participation certificate in the webinar planner. The METAV web sessions will continue on until tomorrow with sessions in German and English. So take the opportunity and listen in on them. And the METAV fair has been postponed to next year, and it will take place on 23rd to 26th of March 2021. And I'm looking forward to seeing all of you at that date in Düsseldorf. So goodbye and have a nice rest of the day.
Okay, thank you very much for your attention and have a nice afternoon. Bye.